we will discuss naive Gauss elimination method to solve system of linear equations. So naive Gauss elimination method. So naive is not the name of Gauss. He is not like naive Gauss. Strictly speaking, naive is a problem. Okay, this is an algorithm which is not stable. Okay, so because of a problem called as okay, anyways, I'll come to that later. Naive Gauss elimination method using which we can solve system of linear equations. For example, as I told you already, let me take this equation. Say you have a11x1 plus, I will take system of equations like this, a13x3, system constant b1. Then I go for what's happening, a21x1 plus a22x2 plus a23x3 is equal to b2, and lastly you have a32x2 plus a33x3 equal to b3. Okay, now here what you have to do is, we will make this way: coefficient matrix multiplied by system unknowns equal to system constants p. All right, now this A, we will convert this to what? Upper triangular matrix. So you convert this to upper triangular matrix through the process of forward elimination, because to tackle down this problem, two steps are required. 2 points are required. First point is forward elimination, and as we understood, second point is what? Backward substitution. Okay, so backward substitution. Now, how many equations we have here? How many equations you have here put together? How many? How many equations we have here put together? Will someone speak out, please?
3 equations.
3 equations.
3 equations.
Okay. So number of equations. So number of equations, n is equal to 3. So how many steps we require to achieve or to perform forward elimination? So number of steps we required. So number of steps in the forward elimination. So these all are important for computations. Okay, you want to measure computational performance, so you need to take all these things. Number of steps in the forward elimination is n minus 1. So I require n minus 1 steps. That means in this example, how many are unequal to 3? So 3 minus 1, so that equal to 2 steps. So I require 2 steps to to go through forward elimination. So within 2 steps, what I can do is, see, in the first step, see what is my A here? What is my coefficient matrix A? My coefficient matrix A is equal to A11, A12, A13, A21, A22, A23. So this guy is my coefficient matrix, A33. Take a simple. Now we will apply forward elimination step, which involves n minus 1 steps to convert the coefficient matrix A on the left side to a triangular matrix, say A on the right side. Now, how many steps we have? N minus 1 steps. So 2 steps. In the first step, what happens here, the first column, whatever we are seeing on the left hand side, it's getting stuck again. The first column, whatever I'm seeing here in the coefficient matrix, this becomes like A11, 0, 0. So, okay, out of two steps, in the very first step of forward elimination, that means by the end of the first step of forward elimination, the first column becomes like this, like A1100, okay? And what about second column? So you see, the moment you come for this second step of forward elimination, and you would see something like this. Okay, this is not like A22. So this why I mean this will change. Okay, say I will put something like some double prime, that will change. Double prime indicates the changed one of A22. That's it. Okay, so therefore, see, after everything, you would see something like this: A23 and A33. Okay, so see, by the end of the first step, this is end of step 1, and this must be by the end of step 2. You will see second column something like this. Are you able to understand this? Are you able to understand this? You have a coefficient matrix on the left hand side. After forward elimination, we need to undergo n minus 1 steps to convert our coefficient matrix to an upper triangular matrix. So as we have n equal to 3, so in 2 steps we can perform this forward elimination. And the very after the end of the first step, you would see something like this: A11, 0, 0. Are you able to understand this? By the end of step 2, you will see something like this. Okay. Now, do you have upper triangular matrix here? Are you seeing upper triangular matrix now?
Yes, sir.
You are seeing upper triangular matrix because below the principal diagonal A11, A22, say double prime A33, you have 3 zeros sitting, okay, all the way like this. So this is how we do. And then backward substitution, I think you know, already we know how to perform that, okay. So now we will start, we will start doing things. So I'll take my system of equations like this. So this system, I have a system of 3 linear equations. Okay. So usually what I do is this. So I'll put this in the augmented form. I put this in the augmented form, something like this. Say I have A11, A12, A13, and I'll put like B1 here, okay? So A21, A22, A23, and so how do we make a beautiful coefficient matrix on the left to an upper triangular matrix on the right through forward elimination process? That we will see now, okay? A31, then we will knuckle down this by one example which is straightforward. Okay, so then it's getting stuck again. Today it's not. So okay, so this is your augmentation. I'm augmenting my constant column to my coefficient matrix like this. Okay, so I have to make this quantity as 0, yes or not? This quantity must become 0. This quantity also must become 0. So how do I do that? Designate this by equation 1, say this is your second equation, this is your equation number 3. Okay, so now your equation number 1 is unnormalized. It is in free state, it's in free form. I want to normalize equation number 1. So to make this element, to make second row first column element as 0, now what do? I'll do this multiply equation 1 by what? A21 by A11. Okay, throughout equation 1, you just multiply by this quantity, by this ratio, a21 by a11. Then what do? So say this, I mean what you call this one is, say, some equation number like this 1 prime. This is equation number 1. This is equation 1 prime. Now what you have to do, you have to subtract this 1 prime from equation number 2. Okay, you subtract this 1 prime from equation number 2, and you'll be having now modified second row. So now you'll be having modified row 2. Now in this modified row 2, the very first element of modified row 2 is what now? It's going to be 0. So how do you see that? So let me accomplish this one now. Multiplying equation 1 by a21 by a11 throughout, including the augmented element, whatever you have, that is b1. Okay. So how do I do that? How do I do? So just multiply a21 by a11 multiplied by, say, you have something like, how do I put? Okay, let it again. What's the problem? a11, a12, a13, b1. Okay, so in the parenthesis, I mean the open brackets, you have equation number 1. I'm multiplying entire equation number 1 by a21 by a11. So once I do this, then what do? Now this is our 1 prime. This modified stuff is our 1 prime. So if you do this, now what do you have? You have like this, like a21. Then what do you have? See, a11 is cancelled out here. Then what do you have? You have a21 by a11 multiplied by a12. And again you have a21 by a11 multiplied by a13. And again you have a21 by a11 multiplied by b1. Agree? I just multiplied,
sir.
right? Simply multiplied. I didn't do anything special. I just multiplied row 1 by this quantity, the ratio quantity a21 by a11. Why are we doing that? To make below the first element. Okay, to make below the first element whatever I have, I just want to make it a 0. As I want to make that stuff as 0, so now I'm taking this ratio, that is, I mean, this is my 1 prime, this is modified 1, and my second row, my second equation is this. I didn't make this a21 as 0 as of now, so I'm going to make this 0. So this is a21, and this is a22, this is a23, and b2. All right. So now you subtract the modified row 1 from the direct row 2. So this guy is what here? My equation number 2. And who is this fellow? Equation number 1 prime. Agree?
Yes, sir.
Yeah. Yes. So you chop this 1 prime from this equation number 2, and you expect this, and you got this 0. Now the remaining stuff you can take it down, a21 by a11, a12, and so this fellow is a21 by a11, a13, and Mr. last term is waiting here to get it occupied this. So a21 by a11, b1. Now hopefully, now whatever you're seeing, you have total 4 terms including 0 in green font. Now can I say this is your modified row 2, right? Agree? Can I put it down like this?
Yes.
Yeah, this is this guy is my equation number 2. Now equation number 2 gets modified like this 2 prime. Okay. Now as expected, the very first element of row 2 is 0. Yeah, this is what we're expecting, and we got this. Now on the same grounds, I would like to make this a31 as 0 again. So how do I make it 0? How do we make this a31 as 0? I want to make this a31 as 0 again. So again, I take the ratio a31 by
A11.
Yeah. So what I
A11.
do is I ensure my usual practice, that is multiplying equation 1 by what here? Equation 1 by A31 by A11. Okay. So if you multiply equation 1 by A31 by A11, now say this is your 1 double prime. I'm just modifying my equation number 1. Then what do? Then you have to subtract this 1 double prime from where? From equation number 3. Agree? So that you will get modified row 3. Okay? This double prime indicates you're modifying that again. So now what is our equation number 1? Equation number 1 is what? A11, A12, A13 and B1. Agree? Agree? Yeah. You multiply this equation number 1 by A31 by A11. So let me use yellow. The wavelength of yellow is medium. So I multiply this by A31. So you multiply like this. So as I multiplied this time the equation number 1 by A31 by A11. So I would take the like 1 double prime. Now what do? I need to subtract this from equation number 3. My equation number 3 is A31, A32, A33 and B3. This is my third row. So from third row you subtract 1 double prime. So let me take my third row in different color. My third row is what here? A31, A32, A33 and here is B3. So you subtract these two. Now what do you get here? So A11 is out in this case, right? With this A11. So what I have here, A31 minus A31, this is 0. Now this is A32 minus A31 by A11 multiplied by A12. And what about this? And this one is A33 minus A31 by, why am I doing all these things without solving a direct example? Because you need to implement the same in MATLAB, say, or Python. Then you have to exercise these steps. You have to generalize these steps and then implement the same in for loop. You can see the beauty. So therefore I'm doing all these things. So now you have to observe this 1 1 3 1 1 3, all these things. Accordingly you have to adjust your I and j elements. Okay, say I for row and j for columns. So you have to adjust your rows and columns accordingly. That means you have to generalize. So you need to generalize your formula. So this is A31 by A11 B1. So now what do you see? See, this is the end of step 1. Under forward elimination, the end of step 1 gives you what? 2 zeros. Agree? That means below A11, now you have couple of zeros. So A21 and A31 both became zeros. Yes or not? Yes or not?
Yes, sir.
Yeah. I have 1 0, the green 0, and I have 1 0, the blue 0 here. So we got couple of zeros. So now I can hopefully put like this. I have here A11 and this is A12 and A13, B1. Now happily I can put this is like 0 0. And accordingly these elements also get modified. Okay, whatever elements you have here, so these elements will get modified and you have something else here. Okay, so you have something else here and some elements. Now this is the end of step 1. The end of step 1 is, first of all you would see this particular column, and this you expect in upper triangular matrix. And by the end of step 2, what do you see? By the end of step 2, what do you see now? What do we want to make by the end of step 2? We want to make
A32 equal to 0.
that's it. So this guy is A32. So this A32 should become 0. And once you have this, now we can employ backward substitution, or we can make use of backward substitution, and then we can find x3, x2, x1, and like this you can solve any equations you have. So solving 3 equations or 4 equations you can do with your free hand, but the problem is once you move, once your system number is getting high, I mean the number of equations in your system is getting high, then there is no second thought. You have to make use of this algorithm. You have to implement this algorithm in your computer. So that's the only choice you have. Okay. Now, without much ado, we will solve an example. Okay. We'll take a simple example. Now, I'm taking an example which is highly safe. And later you will come to know in our subsequent classes you will come to know why this particular system of equations is safe. Is safe. How do you say whether equations are safe or unsafe? That will come to know later. But I'll take one problem statement. So let me take a problem statement. So I would say like this: use Gauss elimination to solve. So you have like 3x1 minus 0.1x2 minus 0.x3 is 7.85, and then you have like 0.1x1, okay, plus 7x2 minus 0.3x3 is negative 19.3, and then you have 0.3x1 minus 0.2x2 plus 10x3 equal to 71.4. So we have 3 equations with 3 unknowns. I have 3 unknowns here, and those are x1, x2, x3, and now we need to find this. Okay, so now we will use naive Gauss elimination method, and eventually we'll understand what is this naive. So naive, see, it indicates it doesn't bother about the pivot element. Both in forward elimination and backward substitution, you may encounter division by 0. Okay, see, for example, what if this element is 0? Yeah, see, in naive Gauss elimination method, directly we are applying algorithm, okay, to find like x1, x2, x3, say. Okay, now what if the very first element is 0? Because every time what are we doing here? We are doing a21 by a11 multiplied by a31 by a11 multiplied by, yes or not? Now in that a21 by a11, if a11 is 0, then what? It's completely gone, right? Or if this a11 is close to 0, if a11 is close to 0, even more problem occurs. Okay, now you know what, if a11 is close to 0, you would see something like you will have round off errors or rounding off errors, you would say. Okay, rounding off errors or the scaling problems, whatever, these are not that simple to discard. So we have to see to that everything. Okay, so those things you have to put in mind. So always see, in computational methods, one of the problems always we have is this division by 0. Okay, so what if and see, this element is called as pivot element, and the very first equation you are seeing, that is called as pivot equation. In the pivot equation, the very first equation, the pivot equation, the very first element here, in this case you are seeing 3 here, right? The very first element is pivot element or pivot coefficient, or I would say pivot element. Okay, usually, yeah, there are two types of pivoting we need to apply to stabilize our algorithm. And one is a partial pivoting and the other is complete pivoting. And we exercise partial pivoting, okay, in this course, because complete pivoting is out of the scope, okay, in this course. Because okay, I will say you later about that complete pivoting, but let's try to complete this partial pivoting in the next class. But for now, we are not using any pivoting concept, okay. Directly we are solving our problem using naive Gauss elimination method. So the naive indicates that uh, you are not caring about the pivot element. Okay, if pivot element is close to 0 or it is 0, then in both forward elimination and backward substitution, you will have to take division by 0 kind of things, and that leads to a drastic situations, okay, in the solving process. Now, as usual, now what I do is, let me designate this one as my equation number 1. This is equation number 2. This is equation number 3. So now what do you do here? Now what do you do? What is your step 1 now? So we need to exercise forward elimination. Yeah, so what do I do? So I need to multiply equation number 1, multiply equation number 1 by what here? 0.1 by 3. Yes or no? Okay. Yes.
Yes, sir.
Yeah. That means I need to see, in the first step, what are we going to do is that we are going to forward elimination. So what are we going to eliminate? We are going to eliminate the variable x1 in these two rows. Okay, so that is what your goal in the very first step of forward elimination. So I require n minus 1 number of steps. So I required n minus 1 steps. That means I have 3 equations, n equal to 3. So I required 3 minus 1, that equal to 2 steps to complete my forward elimination, okay? So multiply equation number 1 by 0.1 by 3. So what is 0.1 by 3? Some factor will get right. So now you subtract. So multiply equation 1 by 0.13, and this one you have to subtract from what? Equation number 2. Okay, so this is your process. Okay, this is your step. Okay, so let me do that. So I have now equation number 1. So I have 0.1 by 3. So multiplied by, you have 3. I have 0. Minus 0.1 minus 0.2, and also include this. This is 7.85. Okay, and then what to do? I have to subtract this from equation number 2, and my equation number 2 is, it's getting stuck. Today it's not my day. I think it's just doing like anything. Okay, let me take another color. Okay, so my equation number 2 is what here? My equation number 2 is 0.17 minus 0.3 and minus 19.3. Agree? So this is my equation number 2. And after multiplying equation number 1 by 0.1 by 3, this is a modified row 1. See, when we multiply equation number 1 by the 0.1 by 3, this entire equation became normalized. Okay, so I normalized row 1. So I normalized a row 1, then you get this. Yes, can someone please help me out here? So what is the first element? You subtract this. So what do you get now?
0, sir.
Okay, 0. And what about this?
7 minus 0.01 by 3.
So what you must get? You must get like 7.00 like this. Yes or not?
Yes, sir.
Yeah. And similarly, if I subtract this, I must get something like negative 0.29 like this. Okay. And this one you must get something like minus 19.5617. Agree? Agree. You just do this. Okay. So now you have row 2 like this. Now what about this row 3? So now I should do this. You multiply equation 1 by what? 1 by what? This one, right? So I have 0.3 by what here? 0.3 by what? 3.
0.3 by 3, sir.
Okay, so multiply equation 1 by 0.3 by 3. Then what do? Then you subtract. This normalized. This is what normalized row 1. You subtract from where?
Equation 3.
Number 3. So what is my 1? My 1 is this. So 3 minus 0.1 minus 0.2. I will upload this in YouTube, don't worry. So I'll multiply this by 0.3 by 3. So this parenthesis quantity is your row 1. I'm multiplying this by the ratio 0.3 by 3. Now I need to subtract this from equation number 3. My equation number 3 is what here? This one, right? So your equation number 3 is this. So I have 0.3 here. I have 0.3 and a negative 0.2. And I have 10, 71.4. So you have 10, 71.4. So this is your equation number 3. And I normalized my equation number 1 second time. So therefore I just took something like 1 double prime just to show it's modified second time like that, okay? There is no other meaning in that. So what you do now, subtract 1 double prime from equation number 3. So now what are we going to get? The first element is 0. Yeah. And what about second element here? What about second element? Someone please help me out. You must get something like this. Yes or not? Now what about this? 10.02 say some 00. And this one is something like 70.6150. Agree? Just manipulate nothing else. Agree?
Yes, sir.
Icon. And this is what your modified equation, okay? So now you put together everything. I have my equation number 1 is this, okay? And I have my modified equation number 3, the last one, okay? You put one down the other. You put one down the other and you would see below this pivot element 3, now you would see this 0 and again 0. Agree? This is what end of step 1. So this is end of step 1. All right. So end of step 2 and backward substitution, we will do it tomorrow. Okay, we'll stop for now. Are we clear so far? Are we clear so far?
Yes, sir.
Yes, sir.
Yes, sir.
Thank you.